here we go. These are examples. These are nonlinear systems. So what that means is one of the two, or maybe both, are not linear. So like this one is obviously, it's x squared, so it's a parabola. In this first one, the first equation is nonlinear, but the second equation is linear. So if you get one like this, then start with the linear equation and solve for one of the two variables. And really, you want to solve for, if you've got a squared variable up here, you want to solve for the variable that's not squared. If you can do that. You'll see in just a minute if you can't. But in this case, that means I want to solve for y. So I'm going to take my bottom equation and solve it for y. So I'm going to subtract x from both sides, and that gives me negative y equals negative x minus 4, and I need it for y, so I'm just going to switch the signs on everything. Y is x plus 4. All right, now I'm going to do substitution, and I'm going to take x plus 4 and plug it back into the top equation for y. So now I have x squared plus, and instead of y, x plus 4 equals 6. And now I have an x squared and an x in the same problem, which means in order to solve this and actually figure out what x is, I got to factor. So I'm going to subtract 6 from both sides, so I can set it equal to 0. And I have x squared plus x minus 2 equals 0. That factors very nicely and easily as x plus 2, x minus 1, which means x equals negative 2 and x equals positive 1. Now, I have two x values, but remember, this is a system of equation, which means I need ordered pairs. So you're going to have two ordered pairs. So now I'm going to take both of these x's and plug them back in. I can plug them into this pink equation because that'll make it real fast and easy. So y, that's, I'm so sad I got to throw this pen away. Well, maybe if I still go like that. It's one of my favorite pens. Okay. If I plug in y equals negative 2 plus 4 and y equals 1 plus 4, y equals 2 and y equals 5. So my ordered pairs are negative 2, 2 and 1, 5. Everybody good? Mm-hmm. Okay. That's not bad. Those are pretty easy. If one of them is linear, they're very simple. We just solve the linear one and substitute back in. They're pretty simple.